Hello and welcome back. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Today we're going to be talking about one of the more basic machine learning algorithms, and those are decision trees. Now, anyone with coding experience will find these very similar to just if-else statements, and that's essentially what they are. Mapping your features down to your classes using condition statements. So without further ado, let's dive into what decision trees are and how we can use them to train a model. Okay, let's go ahead and get started by discussing what decision trees actually are. And I'm going to do this by just defining a really quick and easy example of a decision tree. So within a decision tree, we are going to have some starting condition, and that's going to be this top node right here. And we want that condition to be mapped to some binary answer. So we want it to be equal to yes or a no. So it could be anything from greater than or equal to or less than, whatever will get us to these yes or no statements right here, because we want to start splitting out our data so that we can get to the end results. Now, depending on what our problem is, if it's this easy, then maybe we could stop right here. But a lot of the problems, we're going to have to expand the depth of our tree. And so these two nodes at the bottom are going to turn into their own conditions. And for those who are used to coding, this would be something like nested ifs, where these conditions will be dependent on the ones that come before it. But after we get our tree to a point where we can start mapping it to final results, then that's what we're going to do. And those end nodes are going to be the results that we're looking for. So how does this relate to machine learning? Well, in machine learning, you're trying to map features to classes. So if we can think of it using this tree, then we're thinking of some conditions based on the features that will get us to the very end, and those end nodes are going to be equal to our classes. Now this right here is an example of binary classification, because we have two classes that we're trying to map to, but you could do it to multiple classes if you have the data and if you have the features to support it. Now we can go ahead and I will go through an example problem so that you can actually see how we can map these features to the classes using some real data. So I have this data set here. It's using heights, widths, and weights, and we are mapping them to two classes. So again, binary classification. And so we're going to take these values and we're going to come up with some condition statements within a decision tree in order to help us map to class 1 and class 2. So I have this decision tree drawn up, and the first thing we're going to need to do is we're going to need to come up with those condition statements. So as you can see, I have used the heights, the widths, and the weights, come up with some condition that we're going to compare them against, and as I mentioned before, it's going to give us a yes or no. For example, in the first node, if the height is greater than 1.5, we are going to move to the right. If it's not, or if it's equal to 1.5, then we are going to move left. And we're going to work our way all the way down to these single nodes. And those single nodes are going to turn into our classes. So we have effectively mapped our features all the way down to the binary classes that we're looking for. And now we need to validate how well this model is compared to the actual answers that we have if we're using supervised learning. So we can do that by looking at the original data, and we're just going to run this data through the tree that we just made to figure out what the end result would have been. And doing that, you can see we have some that were predicted accurately, but we have a couple that were predicted inaccurately. So we can come up with some metric. In this case, I'm just using accuracy. Our model was 66% accurate. So now, typical machine learning process, we need to go back and we need to start adjusting those conditions in order to maximize our accuracy. So if we go back to our decision tree, we can start adjusting some of the values that we're comparing against, or adjusting the way that the features are laid out within the tree. And so taking that original tree and turning it into this, we are able to go back, push our data through the tree again, come up with predicted values, and in this case, we have effectively mapped all of our data to the actual values, and we got 100% accuracy. So overall, that's how decision trees work. These were very easy examples of them, but One of the cool things about decision trees, if you're using packages like sklearn, is you can easily interpret how the model is making decisions because you can go ahead and make these trees after they've been trained. And in future problems like the iris dataset, I'll be using decision trees and I'll be showing you how to do that. So stay tuned for those. Hope you guys got something out of this. Definitely like it if you did, and subscribe to the channel if you want more content like this. For now, I'm out, and I will see you in the next video.